Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 900700000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down. But here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now we've got this proportionality sign here, and to make that an equals, all we need to do is introduce a k constant to the right hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x, and that is actually our answer. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason. So corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it. So we get our lines in. We'll go first of all, add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So to make estimates from a scatter graph, we've got to first of all draw a line of best fit, which would be something like this. And what we'll do is to find estimate of test score B, given the fact they got 25 on test A, means that we would draw a line up from test A at 25. Should be here and then across, and that's how we'd make the estimate. But look at where that is hitting our line of best fit. It's hitting it here. What do you notice about this position here? Well, all of our data is down here. We don't know whether this trend continues up at this point here. We have no idea. For instance, if you were to plot a scatter graph of height against age, we would see it would increase like that, but that line doesn't continue on forever. Like, you're not a 10-foot giant at the age of 30. You do slowly stop growing, and so we don't know whether the trend continues. So we call this extrapolation. So we say that the data has been extrapolated, and what that means is it is probably not accurate. So when you have the data outside the range of the data, when you have a prediction, outside the range of the data, we say it's probably not accurate. If it was inside the data, we would say it's interpolated, and that's actually quite accurate. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus, and so we've got 12X, and then on the last bus stop 19 passengers get on, so plus 19. Now for the second bus, well, we start with X and a further 5X come on, because 5 bus stops with X passengers, so that's 6X altogether, and then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less, and the way we show that is with this inequality here. Now all we need to do is solve that inequality, and we've got x on both sides, so we look at the x's. We've got 12x and 6x, so we always take away the smaller amount, so we're going to take away the 6x both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got x is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for x? Now it is tempting to write down 10, but it says x has to be less than 10. So the biggest number we can get that is less than 10 is 9. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. First thing to do with this question is realise what information we have from the question. So it says that the toy car accelerates at that amount. So acceleration is an a. So its a is going to be 7 meters per second squared. And it says for 14 seconds, so that's a time. So the time is 14 seconds. It seems like there's no more information, but there is, because u is the initial velocity and it says from rest. So u is going to be 0. And it's asking us to find the displacement, so the s. And displacement is just a distance with a direction, so it's a vector distance. So we're going to have to look and see which of the formulae that we're given, so which of the 3 formulae we're going to use. So notice we don't have a v, so we're not using that top one, we're not using that bottom one, so we're going to be using that middle one. So we write the formula out, s equals ut plus half at squared. Now we're looking for s, so let's leave the s there. U is 0, so it's going to be 0 times 14 plus half times the a, which is 7, times the 14 squared. Put that into a calculator and you get 686. So the displacement is going to be 686 meters. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared, so that's another 3 zeros. You can see here that that's 1,000,000, so we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him, or her, 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the 2 numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120. And we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left-hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. So we're given 21 to 4 is the ratio. And we're just going to have our lines in, because what we need to do is make the left-hand side be 1. Okay. And to do that, for 21, I need to divide it by itself, divide it by 21. And we're going to do the same to the right hand side. So 21 divided by 21 is 1. Perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. So to find the locus of points that are 10 centimeters away from a point, you need to measure 10 centimeters on a pair of compasses. And then you put the point at A and draw them. Now I'm going to try my best to do this. It's probably not going to look perfect, but I'll do my best. And the length here, which is supposed to be, probably isn't exactly, but this part here is going to be 10 centimeters to get the full marks. And obviously you want the circle to be a little bit nicer than the one I've drawn, but try and get it as perfect as you can. And the best way of doing that is just don't push down too much and just move the page around with your compass being stationary. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9,000,000. And so we're just subtracting them like that. And so we'll get 6991000. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So With a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula, so it'd be half a plus b h, so half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, the next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence. So I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160. Take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So I'm going to write this out again just to give us a bit more space. And the way we're going to solve this is exactly the same as if we had an equation there, well, with an equal sign, obviously. But with this one, if you times or divide by a negative, you've got to flip the sign. We're not going to be doing that in this one, but that would be one of the differences. So we're going to take away 10 both sides to get 7x on the left hand side. Make sure you don't put an equal sign in there, otherwise that is instantly 0 marks. Then we're going to divide by 7 both sides to get x on its own. So it's x is greater than or equal to 11 would be the answer. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe the graph. The red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start, and then because it's thin it will go quicker, so nice quickly, and then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. We can keep this as an interior angle, but it's actually sometimes easier to convert it to an exterior angle. And what you might know is that the sum of interior and exterior angles is going to be 180 because they will always form a straight line. So to find the exterior angle, all we need to do is 180 take away the 170, and that means it will be 10 degrees. So we've already done a different formula for exterior angle, which is 360 divided by n. And something we can do is we can just swap these two things around. And so we can make the formula that n equals 360 divided by the exterior angle. So 360 divided by the exterior angle, well, we know that the exterior angle is 10, therefore n is 360 divided by 10, which would be 36. To find the gradient, we need to find 2 points we know on this graph. So I'm going to pick that coordinate and this coordinate here. And we know that we need to draw a right angled triangle between them. And we find the gradient by the change in y, which is 3, over the change in x, but notice the change in x is 1, so it's going to end up being 3 divided by 1, which is just 3. So a different definition of the gradient is for every 1 we go to the right, how far up we go, which is 3. So we know that the exterior angle is equal to 360 divided by the amount of sides, which we can just call n. And something you can do is actually just swap these two things around. And we can say that the n, the amount of sides, is 360 divided by the exterior angle for a regular polygon. So we just do 360 divided by 5, and that gives us 72. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully. So we're just going to expand the brackets, 7m plus 70. So we're going to go through this shape and work out the area of each of the shapes in the triangular base prism. So we're going to start with this triangle at the front. And the formula for working out the area of a triangle is half times the base, which is 12, times the height. And so that's going to be 54. Next thing I'm going to do is work out the rectangle here. And so the width of it's 23 and the length is 15. So we're going to do 23 times 15, which is 345. We're going to do the base of the triangle, or rectangle, sorry, at the bottom. And so that is going to be 23 times 12. And that is 276. And the next thing we're going to do is this rectangle at the back, which is going to be, I'm going to call D. And that is going to be 9 times the width, which is 23. So that's 207. Now we do have another triangle, but actually that's the same as A. So when we're working out the surface area, we're going to do 2 lots of A plus B plus C plus D. and that gives us 936. So the answer is 936 centimetres squared. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power 4 times y to the power 4, we just add them together, so it's y to the power of 8. First thing we need to do is work out the volume of this prism, and it's a trapezium based prism. So the volume will be the area of the cross section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now a and b are the two parallel sides, which will be this one and this one. And then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything for this will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. To find the resultant vector, we just get the two vectors and we add the tops and add the bottoms. And it's a plus minus 13, so it's 9 take away 13. When we do that, we get 13 at the top and minus 4 at the bottom. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9 over 15. And therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word and in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can divide top and bottom by 3, and that would be 16 over 75. So either 48 over 225 or 16 over 75. So here we've got right angled triangle, we've got 2 of the lengths and an angle involved in the question, so we're going to be using trigonometry. And we're going to start by labelling the sides. So opposite the right angle, we call this the hypotenuse, opposite the marked angle will be the opposite, and the length between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have any number or letter next to it, so we're just going to cross that out because that's not going to be involved in the question. We're going to do our SOHCAHTOA triangles next, and so we've got SOHCAHTOA. Now we crossed out the A, so we're not going to be using Ka or Toa. This question is going to be using sine, so it's going to be sine the angle equals opposite over hypotenuse. The angle is 42, the opposite is 8.2, and the hypotenuse is x. Put in our solving lines. Now if you're ever in this situation, what you can do is you can swap the left hand side with the x at the bottom. Effectively what we're doing is it's timesing both sides by x and dividing both sides by sine 42. When you do that, you get x equals 8.2 over sine 42. Now be careful on the calculator here, because when you type in sine, it opens the set of brackets. Just be sure to close the brackets before you press the equals. So we get x equals 12.254 blah blah blah. And rounded to 2 decimal places, that's going to be 12.25. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect. There we are. Okay, next thing we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile. And we do that by adding the 5 and the 10 together to make 15. So we'll draw a line across from 15 and down, and that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. To find the median, we need to first of all find out what the highest cumulative frequency is. So it's 20 altogether, 20 rocks altogether. And then we halve that. So we go to the 10 here, and all we need to do is draw a line across from 10 and stop where it hits the line and draw a line down from there. And that to me is roughly, what is it, about 17, because the axis is going up in 2s. And so it means the median is 17. To find the length of the rectangle, what we're going to do is we're going to get the area and we're going to divide it by the width. Now, the question says that it wants the minimum length, so we want the length to be as small as possible. Obviously, to do that, we want the area to be as small as possible. If the area is smaller, the length will be smaller. But let's have a look at a couple of fractions. So let's have a look at a half and 1 over 100. Which one of those fractions is the smallest? Well, it's 1 over 100, but what do you notice about the denominator? That as the denominator gets bigger, the fraction gets smaller. So to make something smaller, we actually want the denominator to be as big as possible. So we want the width to be as large as possible. So we're going to find the lower bound of the area. And an easy way to find a lower bound is find the accuracy. Well, it says the accuracy is to the nearest 10. And what we're going to do is halve that. So half of 10 is 5. And then we're going to take it away from the area. So it's 98,540, take away 5, which will be 98,535. Now for the width, we're going to do the same thing, half the accuracy, half of 10 is 5, but we're looking for the upper bound, we're looking for the biggest it can be. So we're going to add that on, 1, 2, 3, 5. And when you do that calculation, you get the answer of 79.78542, blah blah. And it says it wants it to 4 decimal places. So we're going to do 79.7854. So here we're going to solve a quadratic using a calculator, using the quadratic formula. And the reason we know that is it asks us to do it to 2 decimal places, so chances are it's not going to factorise. So we're going to find out what a, b and c are. And a is the number before the x squared, the coefficient of the x squared, which would be 5. B is the coefficient of the x, which would be minus 6. And then c is the number left over at the end. So we're going to write the quadratic formula, but with our values in it. So we have minus b. Now it always puts the values I substitute in brackets. And the reason is that if they're negative, you can make mistakes, especially here. When it's b squared, if you don't put it into brackets, it won't give you the right answer because it will square the 6 and then put a minus before it. Minus 4 times a times c. And if you always put them in brackets, you don't even have to think about it. It'll always be right. And then over 2 times a. Okay, we're going to put that into our calculator with a plus there first. And it gives us 2.320 blah blah blah. And we're going to do the same thing again, but we're going to use our calculator to go back to the plus there, and we're going to change it to a minus, and then we're going to press equals. And that gives us minus 1.120 blah blah blah. So it's 2 decimal places, it's going to be 2.32 and minus 1.12. We're told that y is directly proportional to x squared. And so I'm going to get rid of that proportionality sign by putting in equals and timesing the right hand side by k. Now we're told that x is 5 when y is 75. So I'm just going to replace the y for 75 and I'm going to replace the x for 5. So that would be 75 equals 25k. We're just going to solve this by dividing both sides by 25 and find out what k is. And we can see that that's going to be 3. So k is 3. So I'm just going to rewrite this equation here, but instead of a k, we know that k is 3. And k is a constant, so it will always be 3. And it says find out what y is when x is 2. So y equals 3 times, and we're going to replace the x for a 2 squared, 3 times 4, which is going to be 12. So our answer is y equals 12. So we're going to go through one way in which you can do this question. With circle theorems, often there are multiple different approaches, and so if you do a slightly different method, but you've written down all the working and you're happy with it, and you get the same answer, it's probably fine. Just don't forget with these, always show every step of your working out, because normally, say there's 3 marks for this question, 1 will be for the answer and 2 will be for the working out. So the first thing I notice with this question is that we have a lovely triangle coming off a tangent, and whenever we have that, the angle on the outside here is equal to the angle on the opposite side of the triangle. So this is going to be 44 here. I'm just going to remove all of that, and so this is going to be 44 degrees here. So angle BFD equals 44 degrees, and the reason you need to give is the alternate segment theorem, and you have to use those words, otherwise you won't get the marks. Now next I notice that we've got a set of parallel lines here, and we've got a line going through them. And so the 44 degrees there is going to be equal to this one here. And so this is going to be 44 degrees. So we say angle FDE equals 44 degrees. And the reason this time is alternate angles. Put the E in, angles. And again, you have to use the word alternate. Okay, next thing I notice is that we have an isosceles triangle here, here, and here, and the bottom 2 angles in an isosceles, assuming that it's upright, are always equal. So this is going to be 44 degrees here. So angle EFD is also 44 degrees, and again we have to just say that it's an isosceles triangle. Okay, just highlight the fact it's an isosceles triangle. Okay, next thing we're going to work out is this one here, and it's just angles in a triangle. So angle FED is going to be 180, take away the 44 plus the 44, and the reason is angles in a triangle add up to 180 degrees, and so 180 take away the 44 plus the 44 is 92 degrees. And finally, took us a while to get there, but finally we can work out what this angle is, because in total all 4 corners of this quadrilateral here are touching the circle, so it's a cyclic quadrilateral. And so angle, what's it called in the question, angle FBD is going to equal 180 take away 92, and again we have to show the reason of the fact it's a cyclic quadrilateral. And so 180 take away 92 is going to be 88 degrees. So our answer will be 88 degrees. So we know the cuboids are similar, so there's going to be scale factors. And we're given the 2 surface areas, so we're going to first of all start there. And we know that there's going to be a scale factor between them. So what do we times the 9 by to get to the 272.25? So we're going to do 272.25, the big one divided by the small one, to find out what the area scale factor is. And when we do that, we get 30.25. So the area scale factor is 30.25. Now this question is all about volume, but we're going to work a little bit backwards and we'll find out that the area scale factor is the linear scale factor squared. So we're going to work out what the linear scale factor is. So to find the linear scale factor, we're just going to square root the 30.25, the area scale factor. And when we do that, we get the answer of 9. So square root, 5.5 even. Didn't sound right. Okay, so when we square root that, we get 5.5. Now, we know that the volume scale factor is equal to the linear scale factor cubed, because there's 3 dimensions. So we know it's going to equal 5.5 cubed. And so the volume scale factor is going to be 166.375. Okay, so that's the volume scale factor. Now we're given the larger cuboid has a volume of 8984.25, and we're looking for the volume of the smaller one. So with scale factors, to get from the smaller to the bigger, we times it. To go the other way, we just divide. So we're going to divide this by 166.375. And then when we do 8,984.25 divided by the volume scale factor, 166.3275, we get the answer of 54. I'm going to first of all just focus on this rectangle here. And we know that to find the area of a rectangle, you multiply the two lengths. And when you've multiplied them for this rectangle, we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A, we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So the first thing I'm going to do is I'm going to put my lines in, because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30, so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side, because that gets rid of the denominator. And it will be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I am going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1870x plus, was it 56,100? I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1870, and we're going to take that away from both sides. So take away 1870x from both sides, and that will leave 5100x on the left hand side, and then obviously we've got the 56,100 on the right hand side. And we want to get rid of the 5,100, so we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So a is 17. It's always important with these questions to realise what the normal graph will look like before we have a look at what the new function will look like. So it's always good to remind yourself what a y equals sine x graph looks like, and it fluctuates between 1 and minus 1, if I write minus 1, and it goes up first of all at 90, goes back down at 180, down to minus 1 at 270, and then back up at 360. So it's just a simple sketch to help us figure out what's going on with the transformed one. So first thing I notice is there is a negative here, which just means it will be flipped in the x-axis. So this would become like this. And there's also a 2 there, so we're multiplying all the y coordinates by 2. So instead of this going down to minus 1, it will start by going down to minus 2, and it will go up all the way to 2. So we've got a nice idea of how this will look, and so we're going to just start plotting this now, I think. So it will go down at 90, which is, so there, to minus 2, back up to 180 at 0, and then back up to 2 at 270, down to 360, and then it will just go again, 540, up there, and then back down. Not the perfect, not the best graph I've ever drawn, but I think the examiner will understand that I know what the graph will look like, so don't panic about making too many mistakes when you're drawing curves. Just try your best to get it as low as possible, but don't go back and start feathering the lines or anything. So we have the original y equals fx shown in the graph, and it says it has a minimum at 1 minus 1, so it's this one is the black line here. And we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do, but when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.